Okay, welcome back. So we're looking at the sine and cosine ratios, and we're looking at key concepts. The sine and cosine ratios compare the lengths of the legs of right triangles to the length of a hypotenuse. So we're going to be comparing the lengths of the legs of a right triangle to its hypotenuse. The sine and cosine ratios can be used to find side lengths and to find angle measures. And we're going to do both in turn. So this lesson is going to have us doing both. Here's your formula. Sine of angle A. So here, this is angle X. So I guess we should call this A. So sine of angle A will be opposite over hypotenuse. Short form. Cosine of angle A will be adjacent over hypotenuse. So example 1, we have to learn how to use our calculator first. So the first thing you do is you grab your calculator and you need to make sure that you are in degrees. Check out your mode, check out your settings. If there's a problem, see me in class. So 47 degrees. So I take 47 and I hit sine, and that gives me an answer. That answer is 0.7314 approximately. Make sure you can use your calculator and get the same answer. Sine of 63. I get 0.8910 approximately. Use your calculator and make sure you get the same answer. Now, let's talk about what we have just found. You've taken an angle. In this case, it was 47 and 63. You put it through a function called the sine function. And what that did was it changed it to a ratio. The ratio is the opposite side divided by the hypotenuse. That ratio, that division, is 0.7314 approximately and 0.8910 approximately. Had we done a different one, let's say, and I'm making this up, let's say 75 degrees, you would grab your calculator, do 75 sine, and it would take me to 0.9659. So that is what's going on here. Now let's make sense of this. What that means is, if I have a right triangle, okay, and if I have sine of A equals opposite over hypotenuse, there's my hypotenuse. We'll make this angle A. This will be my opposite. So if I now take that and put in some numbers, sine of 47 equals 0.7314. What that means is that this is 47 degrees, and this divided by this equals that decimal. So whatever this length is divided by this length gives me that decimal. And when that happens, it's the sine of 47 degrees. Now, what happens if I want to go the other way? What if I want to take the side length ratio back to the angle that made it? Well, what you do is you need something called the inverse operation, which is sine with a little -1 at the top of it. It's not an exponent. Here it is on my calculator. I have to hit shift sine to get it. You may have to hit second function sine. But in any case, what happens is when you do the second function of 0.7314, it's going to take you back to the angle that made it, which was approximately 47 degrees. See that? So if I now do decimal 8910, second function sine, it should take me back to 63. And it does pretty close. And if I do decimal 9659, shift, second function, sine, it takes me back to 75. So if I need to take a side length ratio, back to an angle, I have to use what's called the inverse function of sine, or the inverse of sine. So going back to our sheet, using your calculator to find an angle measure, you're going to notice that you need to find an angle. You're going to notice that you're given a ratio. That means you need to use sine inverse 0.9613, which will give you approximately 0.9613, second function sine, 74 degrees. So the same thing happens for cosine. You're after an angle. You're given a ratio. So you want to go back to an angle, so you're going to have to use the inverse. Cos inverse 0.06976. Put that into your calculator. And we come up with approximately angle A equals approximately 86 degrees. All right, I'll stop there and I'll be right back with 3 examples.